it's Ms. Huser from 8 Silver, and today we're going over lesson 5, and we're dealing with negative exponents. So we're going to see how these might impact our problems. Alright, so number talk, what's the exponent? So solve each equation mentally. So what this is saying is, I'm just going to kind of rewrite these off to the side. So 100 over 1 is the same as just saying 100. Because 100 divided by 1 is 100. And we need to figure out what exponent can we plug in for x. So let's think to ourselves. If we count how many zeros we have 2 zeros. So we know that our exponent would be 2. And this one you might actually just know off the top of your head. Like 10 squared is 100. So 10 times 10 is 100. Okay, so there's that one. Now we have 10 over something equals 10, or 100 over x equals 10 to the first power. So let's think to ourselves, what is 10 to the first power? Well, 10 to the first power is itself. So anything to the power of 1 is itself. And just to double check, since we do know the exponent, we can plug that into our calculator. 10 to the power of 1 is 10. So let's think to ourselves. This says 100 divided by something equals 10. So what is something we could plug in here for x? Well, if we plugged in 10 for x, let's see what 100 divided by 10 is. Yep, we get 10. So we could just rephrase this as 10 equals 10 to the first power. That is what this is saying there. Now right here, something divided by 100 equals 10 to the first power. Now we covered this in, I think, lesson 2, where 10 to the 0 power just equals 1. So what could we plug in for x to get 1? So something divided by 100 equals 1. Well, 100 divided by 100 would equal 1. So we can just rephrase this as 1 equals 10 to the 0 power. Now right here we have 100 divided by 1000. So let's think to ourselves, what does that equal? Well, when we have, Alright, so right here, let's think 100 divided by 1000. Well, we can just kind of cancel out the zeros. So we're left with 1 over 10. So we can say 1 over 10 equals 10 to the something power. Well, let's see if we notice a pattern here. So when we have 10 to the second power, we have 100. 10 to the first, we have 10. 10 to the 0, and we get 1. So if we kind of just go in numerical order, we can assume that this is a negative 1. So when we have a negative 1 there, we just end up with 1 over our base, which is 10. So we're just going to keep going over some examples to kind of just show us how those negatives impact us. So let's go ahead and look at the second activity here. So exponent or negative exponent table. So let's go ahead and just fill this out using exponents. Well, right here we go to the third power, to the second, to the first. So let's just keep counting down by ones. So 10 to the 0 power, 10 to the negative 1, 10 to the negative 2, and then 10 to the negative 3. Alright, so we're just kind of going in order here because we're decreasing by 1. Alright, so now, using exponents, now we're going to write these as decimals. So just to check, if we were to put 10 to the third power, we would get 1,000. That is what is going on there. And we have a 0.0 at the end, so we're going to write that as a pattern. So 10 to the second is 100. So we'll write that as 100.0. Alright, just because they have a decimal here, so we're going to do the same thing. Now 10 to the first power, well, that would just be 10. 10 to the 0 power is 1. And then 10 to the negative power, we just figured out that that would equal 1 over 10, which is the same as saying 1 divided by 10 is the same as saying 0.1. So 0.1. Now let's see, do we notice a pattern here? So that decimal moves up a spot each time. So we move up 1 and now we're at 100. We move up 1, now we're at 10. Move up 1, now we're at 1. Move up, and now we're at a decimal. So if we move it 1 again, now we have 0.01. So we can just assume we move the decimal again and we'd have 0.001. Alright, so I know when we had 10 to the second power, we would just know that means we're going to have 2 zeros. So it'd be 100. So let's see if there's some sort of pattern here. Right here we have -1. So we have a 0 in front of our decimal. So 1 0 in front of our decimal. Here we have 2. We have 2 zeros. We have a decimal in between. Right here we have 3, and we always have a decimal right before that last one. So there is a pattern going on there. Now let's see this as a fraction. Well, we'd just have 1,000 over 1. And here we'd have 10 over 1, 1 over 1. This time we'd have 1 over 10, 1 over 100, and then 1 over 1,000. So it says as you move towards the left, each number is being multiplied by 10. Alright, so as we move towards the left. Now if we move towards the right, what's happening? Well, we can say we're multiplying by 1 over 10. So we're just doing the opposite. Now it says, how does the multiplier of 10 affect the placement of the decimal in the product? How does the other multiplier affect the placement in the decimal in the product? Well, when we multiplied by 10, so multiply by 10, what that did was it shifts to the right. So when we multiply by 10, it would then shift to the right. Alright, so we multiply 1 by 10, we move that decimal over, so now we have 10. Multiply this by 10, we move that over, now we have 100. Move it over, now we're at 1,000. So that's what I mean by shift to the right. Now let's say we multiply by 1 over 10. Well, we would just shift to the left, so we multiply by 1/10, shift to the left, and now we're at 100. Shift to the left, and now we're at 10. So shift to the left. Alright, now it says use the patterns you found in the table to write 10 to the -7 as a fraction. Okay, so we want to write this as a fraction. Well, let's compare. So, right here, if we have 10 to the third, we have 1,000. If we have 10 to the -3rd, we have 1 over 1,000. So, if we were to have, we know that this means we're going to have 7 zeros, but that negative means it's going to be in the denominator. So, we would have 7 zeros. So, let's do 1, 2, 3, 4, 5, 6, 7. The 10 million there. So, I knew that 10 to the 7th would be 10 million, and that negative is just shifting everything to be in the denominator. Now use your patterns to find the table to write 10 to the -5th as a decimal. Let's go ahead and practice writing that as a decimal or a fraction. Okay, so once again, we know this is a negative, so that means we're going to flip it to then be in the denominator. Right here it's in the numerator. Now we need it to be in the denominator. So we know we're going to have 5 zeros, so it'd be 1 over 1, 2, 3, 4, 5. I almost wrote 5. 1 over 100,000. Now if we want to write that as a decimal, what we're going to do is write out 5 zeros, 1, 2, 3, 4, 5, and put our decimal right in between those first two. Because up here, our decimal is always in between the first two zeros. Okay? So there we go. Now this one says write 1 over 100 million using a single exponent. Okay? Well, let's count how many zeros we have. 1, 2, 3, 4, 5, 6, 7, 8. So we know that'll be to the exponent of 8. But since it's in the denominator, it'll have to be a negative 8. So 10 to the negative 8 power. Now it says use the patterns in the table to write negative 10 or 10 to the negative n as a fraction. So what we'll do is write 10 to the negative nth power would then be equivalent to 1 over 10 to that nth power. Alright, so right here, 10 to the negative 1. Or 10 to the 1 would be 10. Well, if we have 10 to the negative 1, it would then be a fraction there. So whatever it is positive, it is just flipped into the denominator when it's negative. Alright, now let's look here on number 3 here. So now we're just going to match up these patterns. So match each exponential expression with an equivalent multiplication expression. So let's go ahead and do that. Sorry. So right here, this is saying we have 10 times itself twice, and we'll have 3 groups of that. So that's not really showing us exactly what we want. This is 1/10 times itself twice. We just want 10. And here we have 10 times itself twice, and that's happening 3 times. So that one looks like what we did on lesson 3. Okay? So right here, now we have 10 times itself twice, but it's going to be flipped into the denominator for 3 groups. Okay? So that one would end up here. So we have that 10 times itself twice, but since we're to a negative exponent, that means ultimately those groups are going to be in the denominator. Alright, now here we have 10 to the second power. So that means we have 10 times itself twice as a fraction. So that would be like 1 over 10 times 1 over 10. And that's going to happen 3 times. So do we see that? Yep, right here. Alright, now this one, we're going to have what we have here, but then ultimately it's going to be in the denominator. So we're going to have fractions in the denominator, and that's what that looks like. So that is our match there. Okay, so it says write 10 to the second to the negative third power as a power of 10 with a single exponent. Be prepared to explain your reasoning. Okay, so let's think back to lesson 3. Now, when we had 10 to the m to the nth power, that means we can just take 10 and multiply our exponents. Okay? So, shouldn't we be able to do the same thing here? Yes. So, let's take 10 to the second to the negative third and write that as 10 to the 2 times negative 3, which would then equal 10 to the negative 6th power. Alright, now we aren't done. We need to now write that as a fraction. So, what this is saying is we're just going to flip it. So right now, this is going to then be in the denominator. So it's going to look like 1 over 10 to the 6th. Now, since we moved it to the denominator, we can take away that negative sign. Okay? But that is the process we can do there. So now we're kind of using what we've learned on lesson 3 and combining it with what we're learning today. Okay, so now we have some fractions, which we went over in lesson 4. So match each exponential expression with an equivalent multiplication expression. So right here, 10 to the second. That means we're taking 10 times itself twice. 10 to the 5th, multiplying 10 times itself 5 times. No, no, yes, 10 times itself twice, and 10 times itself 5 times. So there's our match. Alright. Now we have 10 to the second, so it's going to look just like what we had here, because those match. Now we're going to have 10 to the negative fifth. So we're going to have 1/10 times itself 5 times. So where do we see that? Right here. Okay. Now I want you to pause and try and do this next one on your own. And if you want to challenge yourself, try the following one, and then unpause and see if you got it right. Okay, so we have 10 to the negative second, so we're going to have 1/10 times itself twice, over 10 times itself 5 times. Well, we have fractions on both ends here. Nope, right here. That matches up perfectly. 1/10 times itself twice, and then 10 times itself 5 times. And then here, this is saying 1/10 times itself twice, and 1/10 times itself 5 times, which matches up with the top one. Alright, now right here it says, write 10 to the negative 7th over 10 to the negative, or 2nd over 10 to the negative 5th as a power of 10 with a single exponent. Okay, well, according to our rule, when we have our fractions here, let me make sure I use the correct lettering. When we have 10 to the n over 10 to the m power, that is the same as saying we have 10 to the n minus mth power. I know it sounds like I'm saying the same letter multiple times. So let's think about that concept here. So 10 to the negative 2nd over 10 to the negative 5th. Well, we're going to take negative 2 and subtract negative 5. So negative 2 minus a negative 5. Which is the same as saying 10 to the negative 2nd plus 5. Now negative 2 plus 5 is 3, so we get 10 to the 3rd power there. Alright, so we applied our rules that we learned in lesson 4 here with our fractions. And now we're just working with some negatives, so be careful when combining. Alright, last one here, and this goes with lesson 2. So, match each expression with the multiplication expression. So right here, 10 times itself 4 times, and times 10 times itself 3 times. Let's see where that's happening. Here we go. Right there. Now we have 10 times itself 4 times, and then 1/10 times itself 3 times. Well, that looks like it matches up here. I want you to go ahead and pause and see if you can match the rest. Okay, we have 1/10 because it's negative, so we're going to be dealing with a fraction, times itself 4 times, and then 10 times itself 3 times. That goes right here, and then the last one matches up there. Both of those are negative, so we're going to be dealing with fractions. Alright, so now it says write 10 to the negative 4th times 10 to the 3rd power as a power of 1. A power of 10 with a single exponent. So let's just rewrite our rule. So 10 to the nth power times 10 to the nth. When that happens, we just add our exponents. So when you have like bases, add exponents. So 10 is our like base. Since those are the same base, we can then add those. So up here we have 10 to the negative 4 times 10 to the 3rd. Those are the same base, so we can just add those. So 10 to the negative 4 plus 3. That equals 10 to the negative 1. Well, we know that this ultimately means we're just going to flip what we have to the denominator. So we have 1 over 10 to the 1 power, but you don't have to write that. Alright, so that is that for today. You will be doing the lesson 5 practice problems, and if you have any questions, please do not hesitate to ask your teacher. Thank you.